Hello viewers, this is Nadia from Economisure. In today's class, we will discuss about the violations of the independence axiom and some paradoxes. In that case, first we will need to learn about what independence axiom is. Suppose there are two lotteries, lottery A and lottery B, and I choose lottery A over lottery B, and there comes another lottery which is lottery C and mixes up with both the lotteries. In that case also, I will choose the lottery A because lottery A is preferred by me, and in the lottery C is mixed with both the lotteries. So I will still choose the lottery A over lottery B. Otherwise, there is a broad discussion about the independence axiom. In today's class, we will not discuss about that. We will discuss that in another video. In today's class, we will only discuss about the violations of the independence axiom and some paradoxes. So let's get started.
So we can see the slides here, the violations of the independence axiom. There are four types of the violations of independence axiom: extreme preference for certainty, smallest size of the support, lexicographic preferences, and worst case scenario focus. The extreme preference for certainty says, in this case, decision maker chooses the lottery amongst all the lotteries depending on the single highest probability. We can see, for example, two lotteries, lottery L and lottery L prime. Here the highest probability among all the probabilities is 70%, and the decision maker takes the decision depending on that highest probability, which is 70%. He ignores the other lottery, and that's the violation of the independence axiom, because the independence axiom says the decision maker should choose depending on the overall payoff or the highest gain he can have from the lotteries. But in this case, the decision maker ignores that and he chooses lottery L over lottery L prime, and that's why the independence axiom is violated. The second violation of the independence axiom is smallest size of the support. The support is the outcomes with positive probability. Here he chooses the small range of outcomes, not the large range, because it is because he finds that between 2 or 3 probabilities he can gain one, and he ignores the overall payoff from the other lotteries. For example, if we can see, lottery L has 2 probabilities, which is a small range, and lottery L prime has many probabilities, which is from $10 to $100. But the decision maker chooses the lottery L over the lottery L prime because it has the smallest size of the support, which violates the independence axiom, because the independence axiom says we have to see the overall payoff. The overall payoff is higher in the lottery L prime, which has the biggest range, but the decision maker chooses the smallest range, and that violates the independence axiom. The third violation of the independence axiom is the lexicographic preferences. If you think of a dictionary, how a dictionary works. In the dictionary, the letters are written in a systematic way, which is step by step, the first letter, second letter, and the third letter. Just like that, the lexicographic preferences works. If we see an example, lottery L and lottery L prime. In these two lotteries, in the first step, the probability in lottery L is 2% and in lottery L prime is 1%. So based on this first step, the decision maker takes decision to choose L over L prime because 2% is higher than 1%, and he ignores the other probabilities. That is the lexicographic preferences. Why this violate the independence axiom? Because if we see in lottery L prime, the highest probability, 99% of getting $2 is in the lottery L prime. The overall payoff is higher in the lottery L prime. But the decision maker ignores that and he chooses lottery L just because in the first step, the highest probability is in the lottery L prime. The fourth and the last violation of the independence axiom is the worst case scenario. In this case, the preference of the decision maker is the worst possible outcome. He prefers the worst possible outcome to avoid. If we see an example, again, two lotteries, lottery L and lottery L prime. Lottery L shows the lowest or the worst possibility, which is lottery L, uh, which is 10%, $10, and lottery L prime shows the worst possibility, that is minus $50. That means $50 will be the amount of loss in the lottery L prime. So in this case, the decision maker avoids the lottery L prime and chooses lottery L because lottery L prime has the worst possible outcome, which is minus $50. But this is a violation of the independence axiom. Why? Because the independence axiom says we have to see the other possibilities of the gain also. Here the overall payoff or the overall possibility is better in lottery L prime because it has probability of $200, $150, but the decision maker ignores that just because he chooses to avoid the worst case scenario. That's why he ignores the overall outcome of the L prime and selects lottery L, and that violates the independence axiom. Now we are moving to some paradoxes. And the first paradox here is the Allais paradox. The Allais paradox states that the fear of loss, excitement of big wins, and such emotions often guide choices more than logic. So we can see an example here. There are three possible monetary outcomes in a lottery. First prize is $5 million, second prize is $1 million, and third prize is nothing. The first choice set says there are two lotteries. Lottery L1, which says that there is the probability of sure $1 million, and the L1 prime says there is 10% chance to win $5 million, and 89% chance to win $1 million, and 1% chance to win $0. In this case, the decision maker or most of the people choose a lottery L1, which is risk averse decision, which is the preference of certainty. They fear the fear of the loss guides them to make this decision. The fear in the lottery L1 prime makes them to choose lottery L1, and there is another choice set. The choice set is L2 and L2 prime. The first choice in this lottery is 11% chance to win $1 million, 89% chance to win $0, and L2 prime says that 0.1, that means 10% chance to win $5 million, 90% chance to win $0. In this case, most of the people choose lottery L2 prime rather than lottery L2 because they want to take risk in this case for the big prize, because lottery L2 gives the bigger amount, which is the $5 million. So what's the paradox here? The paradox here is that rationally, if someone chooses lottery L1 more than lottery L1 prime, then he must choose L2 rather than L2 prime. That is the independence axiom. But in this case, the pupil first chose lottery L more than lottery L1 prime, and then they chose lottery L2 prime more than lottery L2. We can see another paradox, that is the Machina's paradox. The Machina's paradox is here the expected utility theory has a strict logic that when choosing between similar risky options, emotions like regret or disappointment drive choices. What does this mean? We can see an example. The example shows the three outcomes: trip, movie, and stay home. Here, trip is the most preferred one, and movie is the less preferred one, and stay home is the least of the preferences. So there are two lotteries, lottery L1 and lottery L2. L1 says that there is 0.99% to achieve a trip, and there is a 0.01% of chance to achieve the movie, and there is 0% chance to stay home. So the expected utility prediction is preference should not change, because there is the preference where the movie is most preferred, then stay home. Trip, trip is the highest preferred, but movie is preferred more than stay home. But in this case, we can see an observed behavior where many choose L2, which is irrational, because this is the violation of the independence axiom. Because we can see 1% chance of only a movie feels very disappointing after getting almost getting a trip. And the worst case is stay home, but still this disappointment is lower since it was expected from before. So the Machina's paradox says the movie is preferred to stay home, but the disappointment guided people to choose home rather than movie after losing the trip. So we can see here, this is called the Dutch books. What is Dutch books? When individuals behave in ways that violate the rules of rational choice. The pupil takes decision different from the rational choices or the expected utility theory, such as the independent axiom. They can be systematically tricked into losing money. When they violate the independence axiom, systematically they can be tricked into losing their money. This situation is known as the Dutch books. The concept is that rational behavior protects individuals against guaranteed monetary losses. If someone behaves in rational ways, that protects him or her against the guaranteed monetary losses. If the independence axiom is violated, individuals become vulnerable to the Dutch books. There are some steps we can see. Suppose an individual initially owns a lottery denoted by L. Then the individual is offered a compound lottery expressed as alpha L plus 1 minus alpha L prime in exchange for paying a small fee denoted by X because of his preferences. He accepts this offer. After the realization stage occurs, the individual will either end up with L or L prime. If the outcome is L prime, the individual is offered the chance to pay another fee denoted by Y in order to trade L prime back for L. Since the individual prefers L over L prime, he accepts this time too. If the outcome is L, the individual is offered once again the compound lottery alpha L plus 1 minus alpha L prime in exchange for a fee of Y. Since he prefers the compound lottery to L, he also accepts this one. So what we get from this? The final result is, in either case, the individual ends up the exactly same position which he started before, either holding L or the compound lottery alpha L plus 1 minus alpha L prime. However, through this process, the individual has lost the amount of X plus Y and he gained nothing. This process can be repeated indefinitely, which means that money can be continuously extracted from the individual. If the individual violates the independence axiom, he can lose his money so many times. So the implications: individuals whose preferences violate the independence axiom can be repeatedly exploited through Dutch books. Such individuals are referred to as money pumps because they can be used to extract money without limit. Someone can cheat them or make them lose their money whenever they want. Subjective probability and Ellsberg paradox. Until now, we assume probabilities are objective, like from coin tosses or dice. But people might instead hold probabilistic beliefs about likelihood of a certain event. That is the subjective probability. Imagine a decision maker who prefers a gamble, $1 in state 1, $0 in state 2, which is preferred to $0 in state 1 and $1 in state 2. If the value of money is the same across states, then he must be assigning a higher subjective probability to state 1 than to state 2. A decision maker prefers the first list of monetary outcomes to the second if the subjective expected utility from the first list is larger than that from the second. The last paradox of today's class is the Ellsberg Paradox. The Ellsberg Paradox says that two things can be true simultaneously. For that, we can see that an urine contains 300 balls, 100 red, 200 blue, or green, that is unknown. So two set of gambles, set one is $1,000 if red and $1,000 if blue. In this case, most people choose lottery A because they know that red is there and 100 balls are red. So they trust the known probability one rather than blue. In the set 2, it says $1,000 if not red, and it says that $1,000 if not blue. In this case also, most people choose C over D because they avoid the uncertainty about the blue. They know that red is certain and they decide to choose lottery C. That's the paradox because both can be true at the same time. Contradiction with expected utility theory, because expected utility theory says that simultaneously we cannot choose two contradictory lotteries. People show aversion or fear of unknown chances. Human decisions often deviate from rational probability logic. In this case, the people don't think of the rational probability logic. They don't think rationally. They just choose from their intuition, and they choose the certainty they have.
So that's all for today's video. Stay tuned with us for more videos like this. If you found this video useful, then like, comment and subscribe.